All right, I'd like to welcome you to today's lesson on the laws of exponents. Now I know that sometimes this can get to be a little confusing, so we're going to try and clear things up. Now remember, when we're going to be talking about laws of exponents, we're looking at an exponent. And the anatomy of an exponent number is you have, say, x cubed. X here is your base, and this is your exponent. And it's hard to remember, but you need to remember that this is your base and this is your exponent. It's critical as we talk about these things. So when we look at the basic rules or the basic laws of exponents here, let's take a look. All right, so for this one that we would have, we're going to take, first of all, let's look at multiplying exponents. So let's say I had x cubed times x to the fifth. Well, when we have two exponents that have the same base or like bases, you keep your base. Here my base is x, so x and x, I keep that the same. Right? You keep your base and you add your exponents. So this is going to be x to the eighth. Remember that x cubed is the same thing as repeating, means you're multiplying x by itself 3 times. X to the fifth, you're repeating it by itself 5 times. So this times this is going to be x to the 1, 2, 3, 4, 5, 6, 7, 8, x to the eighth. So again, when you multiply two exponents that have like bases, you keep your base and you add your exponents. So say I had z to the fifth times z to the 11th. Right? Again, two like bases. The bases are the same. So I'm going to have z. So I keep my base, z, and I add my exponents. 5 plus 11 is 16. So in multiplication, we keep our base and we add our exponents. Now let's take a look at division. So let's say I had x to the fifth divided by x squared. Now we just did multiplication. And when we did multiplication, we kept our base and we added our exponents. Well, what's the opposite of multiplication? Is division. So in this instance, we're going to do the opposite thing. So we're going to keep our base and we're going to subtract our exponents. So 5 minus 2 is 3. So we get x to the third. Now again, if we were to do this and draw it all out, x times x times x times x times x, which is x to the fifth, over x times x, which is x squared, we would cancel to 1, and we would be left with x multiplied by itself 3 times, which is x cubed. So we would have that. So again, the law of the exponents is that if I have like bases and I'm dividing like bases, I keep my base and I subtract my exponents. 7 minus 3 is 4. So y to the 7th divided by y cubed is y to the 4th. Next law of exponents is when we raise a power to a power. Okay, so let's say that I have x cubed and I'm raising that to the 5th power. In this instance, the law of exponents, because I'm raising a power to a power, I keep my base, which is x, and I multiply my exponents. 3 times 5 is x to the 15th. Now again, if we were to draw this out, again, it would be x times x times x is x cubed, and then I'm raising that to the 5th power. So I would do this 5 times. Right, so now I have this 5 times. So if you add all of those x's up, you're repeating this multiplication of x 15 times. So again, when we're raising a power to a power, x to the 7th raised to the 3rd power, we keep our base and we multiply our exponents. So that would be x to the 21st. The next law of exponents that we have is that anything to the 0 power is 1. So anything to the 0 power is 1. So if we were to look at this, right, if we were to look at the pattern, so say I have x squared, or here, let's do this again. Here, let's do this with numbers, right? So I say I have 3 to the 1st, 3 squared, 3 to the 3rd, 3 to the 4th, 3 to the 5th, right? 3 to the 1st is 3, 3 squared is 9, 27, 81, 243. Well, what happens here each time? We multiply to go up, we multiply by 3. Well, to go the other direction, we'd have to divide by 3. So 27 divided by 3 is 9. 9 divided by 3 is 3. So to go the other direction to get 3 to the 0, 3 divided by 3 is 1. Let's do it with 4. 4 to the 1st, 4 squared, 4 cubed. 4 to the 1st is 4. 4 squared is 16. 4 cubed is 64. Again, we're multiplying by 4 to go this direction. To go the other direction, divide by 4, divide by 4. So that means 4 to the 0. 4 divided by 4 is 1. So our law for exponents is anything raised to the 0 power is 1. Then our last law of exponents is that anything to the negative power, it means it's the reciprocal, 1 over x cubed. We have 1 over x cubed. Let's take a look at this one. Now remember, if I had x squared over x to the 6th. Now our rule that we just had was that we keep our base and we subtract our exponents. 2 minus 6 would be x to the negative 4th. Now let's draw this out. So x squared is x times x. X to the 6th is x times x times x times x times x times x. Now again, when we cancel things, we can cancel 1 for 1. So that cancels to 1. This cancels for 1. Now what do I have left on top? Well, I don't have, everything's canceled to 1, so I left with 1 on top. And then x times x times x times x is x to the 4th. So we've just shown that x to the negative 4th is equal to 1 over x to the 4th. So again, anything to a negative power is the reciprocal, is 1 over y to the 5th. And that's our last law of exponents. So just to review, when we multiply two like bases, we keep our base and we add our exponents. 3 plus 2 is 5. When we divide, we keep our base and we subtract our exponents. So we get x cubed. When we raise a power to a power, we keep our base and we multiply our exponents. 2 times 4 is 8. We can z to the 8th. Anything to the 0 power is 1. And anything raised to a negative exponent is 1 over, or the reciprocal of that exponent. So it's 1 over a cubed. I hope this shines a light for you on laws of exponents. And good luck on all your quizzes and tests.